Welcome to part 4 of our lecture series on using our Raspberry Pi to create our very own smart doorbell. In part 1 of this lecture series, we physically set up and aligned our Raspberry Pi and then took an alignment image that we then masked and grayscaled and resized, all for the purposes of part 2 of the lecture series, where we created a detection algorithm that detected change between a first and second image. In part 3 of this lecture series, we incorporated a path to automatically upload an X second long video to Dropbox. And then in part 4 of this lecture series, we'll continue by emailing the first and second image to the user, thereby notifying the user that someone or something entered the user-defined area. And we'll go ahead and use Twilio to also notify the user by sending him or her a text message. To accomplish this task of sending an email from our Raspberry Pi to notify the user, we'll take advantage of what is referred to as a simple mail transfer protocol. Now, this internet standard was developed in 1982, and it's essentially a program that will deliver an email from a local computer to some sort of configured server. So we'll take advantage of this functionality by using the SMTP package available for Python, and we'll run that on our Raspberry Pi. Before we get started looking at the SMTP functionality, I'll make a recommendation here. For the purposes of this lecture series, I recommend go ahead and creating a new email account. I like to use Gmail preferably. And the reason is that you can keep this email account and any security considerations or any functionality separate from your personal or your business or school email accounts. So I'd go ahead, take a second, go ahead and create a new Gmail account, keeping track of the email name and password. Once you have your new Gmail account created, go ahead and boot up your Pi, and let's confirm that the SSMTP and MailUtils packages are installed. I'm going to go ahead and boot up my Pi and jump over to Putty such that we can take a look at some actual code right now. Here I've puttied into my Raspberry Pi, and let's go ahead and get started with some code. I'll begin by typing sudo apt-get install SSMTP and MailUtils. And do I want to continue? Hit Y for yes. Looks like on this Pi I need to update all of the packages. So I'll go ahead and run a sudo apt update. You may or may not need to run this on your Pi, but if you're unable to install SSMTP or MailUtils, I recommend this sudo apt update and then sudo apt full-upgrade. Okay, once we've successfully updated this Pi, let's go ahead and clear the screen and let's try to reinstall SSMTP and MailUtils. Do I want to continue? I'll hit Y for yes. And it looks like everything has successfully installed this time around. So running that update and upgrade was the key for my Pi. With both packages installed, we now need to update the SSMTP configuration file. So let's take a look how to do that. We need to enter this command into our terminal window. So we'll do that here. I'll type sudo nano \etc /SSMTP /SSMTP.config.conf. Once I'm in the configuration file, I need to go ahead and update the mail hub. So I'll just go ahead and copy and paste the rest of this mail hub call. This equals smtp.gmail.com with the port of 587. I'll page down here and right click to paste that information in, and I only need one equal sign there. Next step will be to enter our username, password, and all of the authentication details for this SSMTP configuration file. So you want to use the Gmail account that you created earlier in the lecture, and we'll page down, and right after this host name equals Raspberry Pi, let's enter the following information. So we'll say auth user equals, in this case, it'll be the Gmail account that you created. I'm going to go ahead and use a separate email account that I have from a different course. So I've got auth user equals my username at gmail.com. Go ahead and type in the password to your Gmail account, and then we'll add a use start, capital START TLS. That'll be equal to yes in this case. And then do we want to use the TLS? That'll be yes as well. So be sure to enter in your user and password information for your Gmail account. With all that information entered in the configuration file, go ahead and Control X and save that file. And we'll just come back here and clear out this screen. Let's go ahead now and generate our first script to start putting some of this theory to practice. So I'll go ahead and create a script. Here in the notes I have it as email01.py. I think for the purposes of this lecture I'll just go ahead and call it tests_email.py, but certainly you can call it whatever you'd like for this exercise. We'll go ahead and test out this script, and then we'll implement this functionality into our smart doorbell algorithm. So let's type sudo nano test_email.py, and let's begin by importing all of the packages that we'll be using for this exercise. So I'll import OS from datetime. I'll import datetime. We need to import the SMTP library, so that's SMTP lib. From the SMTP library, we need to import capital SMTP. We also need to import capital SMTP exception with a capital E. Let's go ahead and import the email package, and from email.mime.multipart, we need to import the MIME multipart with capital letters there. And from email.mime.text, let's import MIME text, and finally from email.mime.image, we'll import MIME image, again with capital MIMEs. And once these packages are imported, let's just print something to the terminal screen here just to tell the user that everything has imported properly. I'll go ahead and Control X to save that file. And let's go ahead and run it just to make sure that we're able to import all of the required packages successfully. So in this particular Pi, I'll type Python 3 test email, and good. Looks like everything is importing properly. Let's continue adding to this test email script. We'll go in and type sudo nano test email again, and let's page down. And from here, let's go ahead and enter some timestamp information. So I'll say here, define timestamp and record an image. I'll create a variable called PicTime for time of picture, and we'll set that equal to datetime.now, left right parenthesis dot string f time. And again, as we were doing in previous lectures, we'll give it a year, month, date, hour, minute, second tag, right? So PicTime will be a string with the current year, month, date, hour, minute, second. And we'll come down and type in our typical command. So we'll say command equals raspi still. We'll give it a width of 1280, a height of 720. Here I'll vertical flip it and horizontal flip it based on how my Raspberry Pi camera is mounted. We'll add to that command string the PicTime, and then of course we'll be saving this as a .jpg. We'll use the OS package to execute that command. So let's Control X and save and run this script to verify that this runs properly. Looks like the packages have imported properly, and there we go, right? So we have successfully imported our packages and recorded a image. Let's continue then. So we'll sudo nano test.email.py, and now we've imported the packages, we defined a timestamp and recorded an image. Let's begin entering the email information. To begin, I'll type in SMTP user with a capital U. That'll be the email account that you created from which you'll be sending the email. And then we'll define that SMTP password. And again, that'll be the password to your Gmail account. With the username and password entered, let's go ahead and define the destination email. So who is the person or persons we want to email? In this case, I'll just add a to add. That'll be my email address. Feel free to send the email to whoever you would prefer. And then the from add, that'll be the SMTP user, right? That'll be that Gmail account that you had just created. We'll give the email a subject. I'll say image recorded at, and I'll tag it with pick time, so that'll give it a unique identifier. And then we'll create the message here, right? So MSG will be equal to MIME multipart. We'll go in and define the subject part, MSG left bracket, subject, right bracket. That'll be equal to subject. We'll go in, define the from component of the message. So MSG left bracket from right bracket. That'll be the from add. That's the SMTP user as we defined above. And then we'll define the MSG to, and of course that'll be the to add, right? That's the destination email that we want this email to be delivered to. Let's go in and define the preamble for the message. We'll say the image was recorded at, and we'll tag that with pick time. And then we'll continue now by defining the text of the email. So let's define the body of the email. That'll be body equals MIME text. And let's just give it something simple again. We'll just say image recorded at pick time. Certainly you could define the body of the email as you desire. Let's go ahead and attach the body of that to the message. So we'll use a msg.attach and we'll feed it body. And from here, let's attach that test image that we took with the rasp-still command. So we'll say fp equals open, and we'll open pick time. That's the string with a unique identifier, and we'll add to that the .jpg. We'll say img equals MIME image, and we'll pass that an fp.read, and then we'll fp.close. Now we need to attach then the image to the message. Once again, so we'll use an msg.attach. We've attached the body. We're now attaching the image. And from here, let's go ahead and send that email. So we'll say s equals smtp lib for the smtp library dot capital smtp, and we'll give that the smtp.gmail.com, comma with the port of 587. We'll come in here and say s.ehlo, left right parenthesis, s.starttls, s.ehlo, and then let's give it the login information, right? So we'll say s.login, that'll be SMTP user with the SMTP password. That's again to the Gmail account that you've previously created. We need to define an s.sendMail, so that'll be from add, to add, and then msg.asString. And then finally, let's go ahead and quit. So we'll have s.quit. And then once we're done, let's once again just print to the terminal window here that the email has been delivered. Let's give ourselves some feedback for this particular exercise. So once you're complete, we'll Control X, save that file, and let's go ahead and run it. Okay, interesting. We see we have a authentication error here. Let's pursue that a bit further. If you receive an error of this nature, what has happened is that Gmail has blocked your Raspberry Pi from accessing your Gmail account. This is a security feature. Now there is a workaround for this. So what you need to do is log into your new Gmail account, head over to the security tab, and then go ahead and turn on access for these less secure apps, right? So head over less secure app access, go ahead and turn that on. And again, this is why I was mentioning earlier in the lecture, it's a good idea to go ahead and create a separate Gmail account. Just keep this lecture and this activity completely separate from your personal or business email accounts. Once you've turned on this less secure access, go ahead and rerun the script, and that should take care of that error. Great. Looks like our test script works as intended. And if I head over to my destination email address, I see that I have received the email from my new Gmail account. It is appropriately timestamped and has the Raspistill image attached. Let's go ahead and implement this functionality into our Smart Doorbell script. So I'll cd into my Smart Doorbell folder, and I'll sudo nano our script, which was our Smart Doorbell masking.py. First thing we need to do is page down and add the additional packages that we need to import into our Smart Doorbell script. So you could cut and paste those, or as I'm doing here, you could just type them in. With all of the packages added into our Smart Doorbell script, let's page down inside of our if loop here. And now if we've detected someone or something has entered that user-defined area, let's go ahead and email the user the images that were recorded and written to file with our cv2.imwrite commands. Let's begin then by adding to our script, send email to user with images, and we'll go ahead and add in then the SMTP user. That will be the Gmail account that you created for the purposes of this lecture. We'll add in a SMTP pass. That's the password that you've created for your particular Gmail account. We'll define our to add. That will be the email account that you'd like to deliver the email to. I'll put my address for here, but certainly feel free to email yourself this result. And we'll give a from add. That'll be the SMTP user, right? That's the Gmail account that you created. Let's go ahead and define the subject then. That will say Smart Doorbell recording from, and of course we need to add in some timestamp information here. So I'll go ahead and define this as F time for the moment, and I'll need to come back in and define then this F time string. So let's go up above subject, and let's go ahead and do that now. We'll say F time equals, this will be date time dot now dot string F time, str F time, and let's give this string description a %A, %D, %B, and then we'll say that that was recorded at this hour minute. What the string defines for us then is the %A, that'll be day of the week, for example, Monday, %D for a date, for example, the 21st, and %B, so that'll be the month, for example, April, all at a particular hour : minute. Let's continue by defining the message then. We'll say MSG is equal to MIME multipart. We'll go ahead and define the subject. That'll be MSG left bracket right bracket equals subject. Once again, we'll define an MSG from. That will be equal to the from add, and an MSG to, and that'll be equal to the to add. Let's define the message.preamble. We'll go ahead and define that as being equal to, and we'll just say here image at, and we'll tag that with F time. From here, we'll then continue to define now the body of the email. We'll say body equals email.mime.text.mime text. And inside of the body, we'll say smart doorbell video, and we'll tag that with ftime as well. And then we'll go ahead and attach the body to the email with a message.attach, and we'll feed that body. Let's go ahead and attach the images that are written to file inside of our script. So we'll say fp equals open. Here we'll add test0.jpg. We'll give it a comma rb, which will read the file in binary mode. And then we'll define image equals mime image, and we'll pass that in fp.read. So go ahead and read in that image. We'll then fp.close and then attach that to the message. Now we want to use this for all of the images that are written to file. So I'll just cut that text and paste it back in, and then we'll go in and redefine all the images. So we have test 0, test 1, we have a gray 1 and a gray 2, and then we have the masked images. So that'll be masked 1 and masked 2. And that'll be all the information that we can send to the user to give them an idea of how the algorithm has been initiated. From here, we'll define the proper path to deliver the email. So we'll say s equals smtp lib.smtp. We'll give that the smtp.gmail.com with that port of 587. As we were before, we'll define an s.ehlo, s.starttls, s.ehlo, and then an s.login, where we pass the username and password to the Gmail account from which we'll be sending these files. Let's go ahead and send the email then. So s.sendmail, we'll send it from our account to the account that we have defined. And then finally, let's wrap this up with an s.quit. And once again, I'll add into our script a print call to the terminal window to let us know that our email has been delivered. With our script complete, let's save it and run it to see if there are any errors that need to be accounted for. So we'll type in Python smart doorbell masking.py and run it. And it looks like I have one error here. Looks like I have a single quote on the left of smart doorbell and a double quote on the right. So let's open up this script and fix that error. And go ahead and save this updated file. With our script running successfully, let's head back outside and test this new functionality. I'm outside of the house again, walking from the street up to the door. And in a second here, the smart doorbell algorithm should detect that someone or something has entered the user-defined area. Looks like smart doorbell has detected someone or something at the door. That, of course, is me. So we're now recording a video that will then be uploaded to Dropbox. And after that, we'll email the user the images from this particular detection. You'll notice I received a notification from Dropbox that the file has been uploaded. If I head over to my Dropbox account, we see here then this is the video that was recorded by the Raspberry Pi. Once the something or someone, that something or someone being me, entered the user-defined area, and enough change was detected to initiate that detection algorithm. Let's take a look at the files that have been emailed to the end user in this case being me. So here is the email address that I created for this exercise. We see the day of the week, date, month, at the hour and minute. So at 10:56 a.m., this recording was created. And you'll notice here are our test 0 and test 1 images. Here are the grayscaled and resized versions that are actually used for the detection algorithm. And then here are the masked images to give us an idea of the someone or something entering that user-defined area. That wraps up part 4 of this lecture series on using our Raspberry Pis to create a smart doorbell system. We'll continue in lecture 5 by setting up a Twilio account and notifying the user via text message that someone or something has entered that user-defined area. As always, if you have any questions or concerns, please reach out to me anytime, and I look forward to seeing you in our next lecture.